Hello student, good morning. Myself Kirtkara DB, Sadhguru Gadge Maharaj College Karad, subject physics. Last time we have seen the Piston's bridge, application of Piston's bridge, meter bridge, its construction and working, and use of meter bridge for determination of unknown resistance. We have one formula x equal to r into Lx divided by Lr. Using this formula, we can calculate unknown resistance x equal to r into Lx divided by Lr. But this meter bridge, while using meter bridge, we occur some errors. In this lecture, we will study some errors occurs while using meter bridge and their minimization. First error while using meter bridge. In case of meter bridge, the wire AB to be used having not uniform area of cross section. This is first error occur in the measurement of unknown resistance by using meter bridge. The wire should not be uniform area of cross section. Then second, the ends of the wire A and C are in contact with the metallic strips, L-shaped metallic strips. So, contact resistance to be developed, due to which some errors occur in the measurement of X. Third, the ends of wire are not exactly coincides with the 0 and 100 centimeter mark on the scale. These are three errors occurs while using meter bridge for determination of unknown resistance X. These errors can be minimized by following points. Remove the suitable resistance from resistance box and adjust the null point or balance point along the wire between 34 centimeter to 66 centimeter, that is in the middle 1/3 of the wire. Balance point or null point is obtained between middle 1/3 of the wire, means from 34 centimeter to 66 centimeter. Second point, experiment can be repeated by interchanging the position of X and R. X with the unknown resistance, R with the known resistance, X connected in left gap of meter bridge, R connected in the right gap of meter bridge. So, we have to interchange the position of X and R and repeat that experiment number of times. This is the second elimination with which we can minimize some error involved in the measurement of meter bridge. Third, we do not slide jockey along the wire. We have to tap jockey along the wire. These are three minimization with which error can be minimized. These are some points regarding the errors and minimization of errors while using meter bridge for determination of unknown resistance. Then next point, applications of Piston's bridge. There are a number of applications of Piston's bridge. Among them, first we have studied meter bridge for determination of unknown resistance X. Second application, Piston's bridge is to be used for measurement of low resistance. Third, Stone's bridge used to measure resistance of galvanometer. Impedance, inductance and capacitance. Stone's bridge is used to measure resistance of galvanometer, similarly impedance, inductance and capacitance. Fourth, Stone's bridge used for measurement of strain. And last, post office box is the practical form of Stone's bridge used for measurement of unknown resistance. These are some applications of Stone's bridge. Among them, one of the application is determination of resistance of galvanometer by Kelvin's method. This is one special type of method with which we can determine the resistance of galvanometer by meter bridge. In this case, there is no need of galvanometer to detect a balance point or null point. The galvanometer whose resistance to be calculated is directly connected to left gap of meter bridge and known resistance in the form of resistance box to the right gap of meter bridge. The construction of this method is the same as the construction of determination of unknown resistance by meter bridge. By connecting all the circuit, do not touch the jockey at any point on the wire. Adjust the rheostat such that we will get suitable deflection in the galvanometer like this. This is suppose galvanometer, this is scale of galvanometer, this is 0 point, this is 0, 10, this is 20, this is 0, 10, 20, 30, 10, 20, 30. This is scale on the galvanometer. Without touching the jockey on the wire, adjust rheostat such that this pointer shows some deflection in between 10 division to 20 divisions. Suppose that deflection to be 15 divisions without touching the jockey along the wire. Then touch the jockey at the end A of the wire and observe the deflection in the galvanometer. The deflection in the galvanometer is either towards left or right. Suppose this galvanometer shows deflection 7 divisions towards left. Then remove the jockey from end A, then touch the jockey at end C and observe the deflection in the galvanometer. And deflection is towards right of 7 divisions. This shows that in this method, galvanometer shows same deflection towards left as well as right. Therefore, this method is not a null deflection method, but it is an equal deflection method. In this method, we can't observe null point. Therefore, this method is an equal deflection method, not a null deflection method. This is a special method for determination of resistance of galvanometer. And last, by measuring the balancing length towards G side and R side, that is Lg and 100 minus Lg, we can calculate the resistance of galvanometer using the formula G is equal to R into Lg divided by 100 minus Lg. This is the formula for determination of resistance of galvanometer by Kelvin's method. This is one of the special method for determination of resistance of galvanometer. These are some applications of Bristol's bridge. Now, next point. Principle of potentiometer. Potentiometer is an instrument used for accurate measurement of potential difference. Potentiometer is an ideal voltmeter having infinite resistance. It do not draw any current, so such device called as potentiometer to be used for accurate measurement of potential difference. Construction of potentiometer is like this. Potentiometer consists of thin uniform wire of several meters in length. Is divided into number of equal segments, each of length 1 meter, is stretched on the board between 2 points like this. This is potentiometer wire AB of several meters in length, stretched on wooden board between 2 points A and B. Connect a source of EMF, means battery, having EMF E, having internal resistance R, and this is the plug key K across the wire AB. Suppose L be the length of wire, R be the resistance of wire. When key is closed, steady current flows to the circuit like this. Suppose I be the steady current flowing through the circuit. Then, by using Ohm's law applied for complete circuit, we can write some equation. I is equal to E divided by R plus R. I be the current flowing through the circuit, E be the EMF of cell or battery, R be the resistance of wire, and small r be the internal resistance of cell. The potential difference across wire AB according to Ohm's law, V is equal to IR. This is simple Ohm's law, V is equal to IR. Then substitute the value of R in this relation, V is equal to E divided by R plus R into capital R. Then divide both sides by capital L, that is V divided by capital L equal to E divided by R plus R into R divided by L. V means potential across wire AB, VAB divided by L. That means VAB with the potential across wire AB, means fall of potential difference across wire AB, divided by length of wire, called as potential gradient. Fall of potential per unit length of wire, called as potential gradient. It is denoted by letter K. Therefore, VAB divided by L equal to K. That is E divided by R plus R into capital R divided by L. This potential gradient of wire is always constant because bracket term E capital R small r constant, L length of wire constant, Therefore, write values totally constant. Therefore, value of K is always constant. That constant is called as potential gradient of that wire. Therefore, you can write equation VAB divided by L equal to K, or VAB equal to K into L. Suppose P be any point along the wire at a distance L, small n, from point A. Then potential difference between these 2 points given by relation VAP equal to this constant K, potential gradient K, into length of wire L. That is VAP is equal to KL, or replace the equal sign and constant K to write this equation like this: VAP proportional to L. Means potential difference between 2 points along potentiometer wire is directly proportional to the length of wire between these 2 points, which is the principle of potentiometer. We can define or state the principle of potentiometer like this: follow potential or potential difference between 2 points along potentiometer wire is directly proportional to the length of wire. This is length of wire between these 2 points, which is about principle of potentiometer. Then next point, use of potentiometer. Use of potentiometer or uses of potentiometer. First use, potentiometer is used to compare EMFs of given cells by direct, individual or separate method. This is the first use of potentiometer to calculate the value of E1 divided by E2 by separate or direct method. E1 be the EMF of first cell and E2 be the EMF of second cell. We have given 2 cells having EMFs. First cell having EMF E1, second cell having EMF E2. Then compare the EMFs of given 2 cells, that is E1 by E2, using potentiometer by separate or direct method. For that, we have to draw some figure like this. This is potentiometer having thin uniform cross-sectional wire stretched on wooden board between 2 points A and B, is divided into equal number of segments, each having 1 meter in length. That potentiometer wire is connected to the source of EMF like this. This is source of EMF E. This is positive, this is negative. Connected to the like EK, connected to the rheostat RH, and NB of wire is connected to the variable terminal of rheostat. The given cells whose EMF to be compared is connected to that circuit like this. This is first cell, positive plate of first cell having EMF E1. This is positive plate of second cell having EMF E2. Negative plate of two cells connected to two the keys. Suppose this is K1, this is K2, and common point of these two keys connected to galvanometer. And another end of galvanometer is connected to sliding jockey J. This is about construction of potentiometer for the use of determination of E1 upon E2. That experiment is carried in two steps. Working of that experiment is carried in two steps. In first step, close K1 and open K2. In first step, close K1 and open K2. That means cell K1 is in circuit and cell K2 is not in the circuit. Only cell, first cell having EMF E1 is in the circuit. Then tap the jockey along the wire like this. Obtain a point of contact B along the wire. The galvanometer shows a zero deflection or null deflection and measure the balancing length of wire from point A to D as L1 at which galvanometer shows zero deflection. Then by using the formula we can write some equation like this. E1 is equal to KL1. This is equation number 1. Here E1 with the EMF of first cell, K with the potential gradient, and L1 with the balancing length of first cell when it is connected in the circuit. In that case, the follow potential across the wire having the length L1 is nothing but EMF of given cell E1. Therefore, we write the equation like this: E1 is equal to KL1. This is first part of that experiment. Then second part, close K2 and open K1 so that only cell K2 is in the circuit. Cell K1 is not in the circuit. In that case, close K2, open K1. Then slide the jockey along the wire from point A and obtain the point of contact like this, D dash. Measure the balancing length from point A to D dash. E is supposed to be L2. Then follow potential across the wire A D dash having length L2 is nothing but potential difference or EMF of cell E2. Then we can write the equation like this: E2 equal to K L2, where K be the potential gradient of the wire. In this experiment, the condition is that positive terminal of source of EMF and two given cells, positive terminal of first cell, positive terminal of second cell, must be connected at end A of the wire. We repeat again, positive terminal of source of EMF and positive terminal of given two cells to be connected to end A of wire. This is the important condition of that instrument or experiment, and the source of EMF E must be greater than E1 and E2. E is always greater than E1 and E2. Here, suppose this is equation number 2. Then divide equation 1 by 2. E1 divided by E2 equal to KL1 divided by KL2. Common term gets cancelled. E1 divided by E2 equal to L1 divided by L2. This is the formula for determination of E1 divided by E2. Means comparison of EMF of given two cells by potentiometer using separate or direct method. By knowing the value of L1 and L2, we can calculate the value of E1 divided by E2. Thank you.